Hey there, Dr. Dave here with another EV3 Mindstorms video tutorial. In this tutorial we're going to look at using the line sensor to drive in a straight line. So the first thing we're going to do, we want to drive ahead 4 rotations of the wheels. So we're going to use our motor sensor to keep track of how far we've moved. So first thing we'll do is reset that to 0, and we're going to keep track of the motor connected to port B, so we'll change that. Next thing we need to do is set up some variables. The first variable that we'll define is for the target light value. So this is the value that represents the reflective light value that we'll get when the sensor is midway between the black line and the white surrounding. We determine that value by doing some calibration, where we place the light sensor midway between the black line and the white surrounding. And in this case we get a value of approximately 45. But this will vary quite a bit depending on the ambient light and so forth. So we declare the variable name, so target light, and its value of 45. We also define a variable called gain, which represents the amount that we're going to correct each time. So by making the gain larger, we do a bigger correction. By making it smaller, we do a smaller correction. This is one of these things you'll probably have to experiment with a bit to determine what a suitable gain is. We're going to choose 0.3 in this case. Next we're going to include a loop, and we will continue looping until the motor sensor, so we need to go to the motor rotation in number of rotations, once that is greater than or equal to 4 rotations, and we need to make sure we change that to port B. Next, first thing inside the loop is we're going to get the light value from the color sensor, make sure that it's connected to port 3 or change that appropriately, and we're going to do a calculation. First thing we need to do is read in the target light value, so we change that to read numeric, and we add a calculation block now. So in this mathematical block we feed in the target light value and then subtract the actual light value from that. So we'll change that to a subtraction, and this is then read into what we call an error variable. So we need another variable here, add a variable called error, and input that into there. So this gives an indication of what correction we need to do. So next we'll read in the value of the error variable, so change that to error, and the gain variable, and feed both of them into an advanced mathematical block. So we drag in a mathematical block, we change that to advanced. So make sure we change both of those to read. Do our connections here, and then the calculation we're going to do. So calculation we do up here is the gain multiplied by the error and add power of 50 to that. So lastly we add a tank block. I'm going to change that to turning the motor on. The left motor will just be powered at 50%, the right motor will be powered at this adjusted amount, which is adjusted to take into account the error margin. So we continue driving ahead like that, continue around the loop. Once we exit the loop, we need a command to stop the motor. There's that one there.